Sorry, YouTube, I forgot to turn on my mic. Your fault. Yep. Sorry, Carter. All right, here we go. Who can guess what R sub 4 means? Good. Right-hand sum. What do you think the 4 means? 4 intervals. What is the width of this entire interval? It is 8 units. So if I divide it up into 4 parts, what's going to be the width of each interval? 2. So this is my first interval, my second, my third, and my fourth. So if we're going to do the right hand, remember our formula is to take the width times the sum of the heights. That's what we did on Friday. We took the width times the sum of the heights. The width is 2 times the sum of the heights. Where do we evaluate our first height? We evaluate our first height at 0, and it is 1. Where do we evaluate our second height? 2, and the height is? The third height, we evaluate at 4, and it is 8. And then the height at 6 is 6. Cool. So 1 plus 7 is 8, plus 8 is 16, plus 6 is 22, times 2 is 44. You try the left hand on your own. Go.
You still do that sometimes? I'll be like, left, right? I'll be like, hold on, I forgot what that is. They're like, right.
Did you get 42? Sweet. So for the midpoint, that's going to be a little bit different. Something I want you to know is I want you to see this, that for the right hand, you use 7, 8, and 6. I'm sorry. Get rid of that. Use 1, 7, and 8, which pops up again over there, right? You cut off the last one, and you picked up the first one, right? So that's a tendency, that's a pattern I want you to see develop. The midpoint, where do we evaluate our heights? Yeah, at -1, so you get 10. And then at 1, so you get 5. And then at 3, so you get 16. And then at 5, so you get 5. So you should have 2 times 10 plus 10 is 20. Plus 16 is 36. 72. Question?
No, I see what you do.
Okay. In order to do the trapezoidal sum, simply take the left hand plus the right hand and divide it by 2. So as long as the width of the intervals is the same, which it is, in this case we can take 44 plus 42 and divide it by 2. And what is 44 plus 42 divided by 2? 43. You good? A lot of it just has to do with the behavior of the function. So if you look here, it goes from 5 up to 10, down to 1, up to 5, 7, then jumps to 16. So it just happens to be at the middle. It has a lot of erratic behavior. Okay? Just the nature of the function. Most times it won't work out like that, but in this case it does. Flip it over. I don't want to do example 2. I don't know why it's there. Example 3, approximate the area bounded between the curve negative x squared plus 16, the x-axis, and the y-axis in quadrant 1. So I'm going to draw a picture of the shape up here. Can somebody describe for me what negative x squared plus 16 looks like? It's an upside down parabola. Good. Goes up through 16, right? Where's it cross the x-axis? -4 and +4. I'm finding the area between which spots? It says you're bounding it between the x-axis, which is here, the y-axis, okay, the function, and it's in quadrant 1. So that's the region that we're trying to find the area of. How many rectangles are we dividing it into? 5 rectangles. So can somebody tell me what the width of each interval is going to be? 4/5. Very good. Do you want to use the decimal or the fraction? It's up to you. Okay, we'll use decimal. So I have 0.8 times the sum of the heights. Now, what's always important is to figure out where are we going to evaluate the heights. If this is 0, then what's this spot right here? 0.8, then 1.6, then 2.4, 3.2, and all the way over to 4. I will only draw the right-hand sum. I won't draw out all of them. Can somebody tell me where do I evaluate my first height if I'm doing right hand? I go to my interval and I go to the right-hand side of it. I go to 0.8. So I'm going to draw out the right-hand sum so we can see it. Will be an over or underestimation. Will be an underestimation. You can see there. Great, so I've got my drawing. How do I calculate those heights? Plug them into the function, correct? I would say we should take out our calculator. What do you think? I go on to y equals. I have negative x squared plus 16. Now what would you like to do? Yeah, I think your table is a great option. And what are you plugging in? 0.8, 1.6, 2.4, 3.2, and 4. How many places should I be, for how many x values should I be, how many x values should I be using? 5. Why? Because there's 5 rectangles. Can you understand why that drives me nuts on the test when we have 5 rectangles? I see people only plugging in 3 values. If you have 5 sums, please make sure you plug it in 5 values. Now I get that 4 produces 0, but those are our heights. 15.36 plus 13.44 plus 10.24 plus 5.76 plus 0. Question. What is the height at 4? So therefore my rectangle is a height of 0. Doesn't go up at all. So let's add that up. Let's see what we get here. 15.36, 13.44, 10.24, 5.76, and I get 44.8. And I got to multiply that by 0.8, and I get 35.84. What's going to change if we do a left hand? Yeah. So if I go into my table, my left hand, I don't evaluate the first height at 0.8. I evaluate the first height at 0. Let's see if I can actually get that second insert 0. Will that do that? Yeah, there it goes. I was able to insert a value. So now, and then which one do I leave off? The very last one, right? So you're going to pick up this first one, but you're going to lose the last one. So the left hand picks up the first and loses the last. .8 times 16 plus 15.36, 13.44, 10.24, 5.76. Somebody come up with the result? I got 4864. Which one's easier to do, the midpoint or the trapezoidal? How do we do the trapezoidal? Yep. Add them and divide by 2. 35.84 plus 48.64 divided by 2. You try the midpoint on your own with a partner. Go. Okay, please grab your notes back to this page, and please make sure you have your calculator handy. Please make sure you have your calculator handy. If it is not common for you to bring your calculator to class, please try to do your best to do so, or at least make sure the person next to you has your calculator. I'm going to be pretty busy with you here in a second. So what's different about this example, example 4? You're just given a graph, right? You're not given a table of values, and you're not given a function rule. And so I'm just going to do one of these with you, and I'm going to do M4. What does M4 mean again? M sub 4? The midpoint sum for 4 intervals. What is the length of our interval? 120, excuse me, 120. So if you divide that into 4 parts, what's going to be the width of each one? 30, that's where I came up with 30. So that means that I identify the height at 15, and at 45, and at 75, and at 105, halfway in between all those intervals, right? So what is the width of each interval? 30. Do you understand why some people write 15? It's 15 in each direction, folks. That's a total of 30. What's the height? 20. What's the height midway through here? 60. What's the height midway through here? Was that? 50. And what's the height midway through here? 60. So you can see that 20 plus 60 is 80, and then we have 110, so it's 190 times 30. I'm going to say it's 5,700. So I did the midpoint one. I'm assuming that if you saw an example of that in your homework, you could do the left hand and the right hand. Agreed? So let's get to the bigger idea here, because we're tired of estimating, right? We'd like to come up with some exact values. So what I'd like to do eventually is forget about R sub 4 or R sub 40. How about R sub infinity? So far, we've been able to do this, but we have not been able to do this yet. Okay, this is a big question mark for us. That's what I'd like to begin tomorrow. This is kind of a 3-day lesson. This is a little bit more challenging. This is the calculus part of it. But the R sub 40, let's, instead of doing it by hand, let's use our graphing technology. Is there somebody who'd like to do 40 rectangles by hand? Anybody? Okay, so let's give this a shot then. It says find the area bounded between the curve f of x is equal to sine of x, the x-axis over the interval 0 to pi by constructing 100 rectangles. So we are going to find R sub 100. We're going to find L sub 100, M 100, and T sub 100. First, I think it would be helpful to get an idea of what the graph looks like. Would you agree? So, somebody describe the graph. Okay, wavy, starts at 0, goes all the way up to 1. Where does it cross the x-axis again? pi, right? So at pi over 2, it reaches its kind of its maximum, it comes back down, and it kind of continues on like that. Agreed? So we're looking for this shaded region right here. What is the width of that entire interval? Pi. If we're dividing it into 100 rectangles, what's the width of each rectangle? Is everybody okay with that? I start at 0, I end with pi. What would be the first spot where I'd evaluate my height? Pi over 100. What would be the next spot I'd evaluate my height? 2 pi over 100, right? And then 3 pi over 100. Then 4 pi over 100, so on and so forth, right? So I'm just going to write the first 2 down. I got pi over 100. I'm going to write 2 pi over 100, which, as Colin said, is pi over 50. Let's go all the way to the end. Isn't pi the same as 100 pi over 100? So what would be the one before it? 99 pi over 100. What would be the one before that? 98 pi over 100. So I'm just, it's all kind of smooshed together, but does everybody see that my first few spots are 0, pi over 100, and 2 pi over 100? Does everybody see that my last spots are 98 pi over 100, 99 pi over 100, and then 100 pi over 100? We good? Okay, once you've done that, you can now figure everything else via your graphing technology. Take out your calculator. Write this down. So, we're going to give you a quick way to kind of navigate through this piece. But this is the formula that we're going to write down. So we'll write it down for the right-hand sum. We probably won't be able to finish all 4 of these before class is over, but at least we'll get a good start. This will help you take care of some pieces of your assignment. We'll be able to pick up some of the issues tomorrow and be able to get to our bigger topic as well at some point after we answer a few questions. So what is the width in this scenario? So I have pi over 100. And into my calculator, I'll type in pi over 100. I will type sum. I'll type sequence. And I list then the function. What's my function? Sine of x. I also then write x. What's the first spot that we will evaluate our height if we're using a right-hand sum? Pi over 100. What is the last spot we'll evaluate our height if we're doing right-hand sum? Pi, right? We're going to the right side of the interval. And then we have to list the width. What's the width? Pi over 100. Now, I want to make sure everybody understands where this came from, because we didn't just make this up out of nowhere. Remember, we've been doing the width times the sum of the heights. Agreed? So this is the width times the sum of, and this will produce the heights. Here's what it does. It says, first of all, plug in all of your x values into this function, which is what you've been doing, right? You take your x values, plug them in the function. It says, start with pi over 100. and go over pi over 100 all the time until you get to pi. So let's say start here and go over pi over 100 all the time until you get to pi. That's the command that we're giving it. Everybody see that? So now let's just actually do it in our calculator. So see if we can find these commands. So we turn our calculator on. And first thing is make sure that you're working in radians and not degrees. So you press mode. Since we're using a trigonometric function, let's make sure we're in radians. I quit that, and now we're going to type in pi over 100. Your pi button is right on the caret key. Divided by 100. And now we've got to come up with a few commands we're not familiar with, right? The way we get to sum and sequence is I like to use my catalog. Catalog is this yellow key right here. It's on the 0. So I press second. That allows me to grab the yellow keys, second catalog. And notice how I'm at the A's right now. I'd like to skip to the S's. Anybody else? So I press S, and it allows me to skip to the S's. The S is in green right here. It's on the natural log button. Nope, you can just hit it. And I move down until I get to sum. And yep, there it is. Sum, I've got it right there. Looks like I could have pressed T and then just backed up one. I would have been there instead. And I press enter. I'm going to pause. Is anybody falling apart right now? Anybody need help advancing past that? Because that's the most difficult part. That's okay in this situation. Okay, now we need to grab sequence. Same thing. Second catalog, S for sequence. There are 2 sequence options. You choose the one with the parenthesis on it. Sequence. Anybody want to guess what I type in next? Yep, now I just follow the command. Sign of X. Oh, it added a parenthesis. Make sure I close it. I need a comma. Anybody know where the comma is? Yep, right by the parenthesis above the 7. What do I type in now? X. Type in X right there. Comma. There is a comma. It's right here up above the 7 or next to the parenthesis. Then I type in pi over 100. Then I type in pi, and then I type in pi over 100. I double close my parenthesis, and I press enter. Anybody want to guess what the exact area is? It's 2. I mean, we've come up with a pretty good approximation, haven't we? Now, the bell's going to go in here for a second. Some of you are going to try this on your homework. We need to finish up this example tomorrow, but I just want to show you guys before you go off and do too much work. Wouldn't it be a pain in the butt to have to enter that 4 times? Watch something really cool. I press second entry, and I pull back everything I've just done. Because I'm going to keep a lot of that stuff for my left hand, aren't I? What's the only thing that's going to change for the left hand? Yeah, the beginning and the end. Those are the only 2 things I need to change. See what I'm saying? So before you delete stuff, just press the second entry and then go in and manually change those. And that'll save you a lot of time. So we'll pick that up tomorrow. I appreciate your work and your focus. You have some time to work tomorrow and try things out. Good work. See you in a little bit.